So, you just told me if I'm going to expand this to the fourth power, the x's get smaller, so they start at what power? They start at the fourth. Now, here's the difference. Because that's a 3x, howdy. Oh, you're here now. Hold on a second. Okay, so, one more time. I want to start out, since you can't just go x to the fourth, x to the third. It is really, really, really mission critical that as you do this, since the x's go down, you have to use the parentheses or you will mess this up. It's 3x, that whole term to the fourth power, not just the x. Okay. Depending on how big a power you're doing and how big you handwrite, some people choose to do these problems going sideways on their paper, where they get out a piece of plain white copy paper or something. This one's not that bad, but you're going to leave yourself space because there's going to be several more things we're going to write in between these terms. So the next one, you just drop them a power. 3x cubed, 3x squared, 3x to the first, and technically 3x to the 0. You wouldn't have to write that one, but I'm going to put it there just as a reminder. Okay, so then what did the y terms do? They increased the power, starting at what power? Where did our y start here? 0. You had no y term. So that's actually probably more critical that you remember the y's start with 0. So I would have negative 2y, and notice I have the minus with me. That matters. So I'd have negative 2y to the 0. What would be the next one? Negative 2y to the first. Negative 2y to the second. Negative 2y to the third. And negative 2y to the fourth. Okay, notice, what do all the powers add up to? 4 plus 0, that's 4. 3 plus 1 is 4. 2 plus 2 is 4. That's a way to double check that you haven't skipped somewhere. All the powers, whatever that starting power is, everything should add up to that power. Okay, then last but not least, before we simplify this into one big number, we need the coefficient numbers that go in front. So where are we getting the numbers that go in front of this? Pascal's triangle. So how would you know which row to go get? By the power. So if it's the fourth power, you want row 4, but be sure you remember your start counting with row 0. So 0. So if you just have Pascal's triangle made, you count 0, 1, 2, 3. Fourth row is 1, 4, 6, 4, 1. So you could come back in here and just throw in the 1, the 4, the 6, the 4, and the 1. Okay. Technically at the moment, we just put plus signs between these. That may change as we work this out. Okay. If I see these messed up, it's right here in the number crunching. Okay. This should come out to be some number x to a power, y to a power, plus another number x to a power, y to a power. It should come out looking like normal algebra. So therefore, all those coefficients you have in there have to get combined together. Now this first one's not a big deal. Technically, though, you have a 1, you have a 3 to the 4th, and you have a negative 2 to the 0. You need to get all those coefficients combined into one number. Most of these you're going to have to throw in a calculator. This one, okay, negative 2 to the 0 is 1, so that doesn't matter. So all you really have to know on this one is that it's 3 to the 4th or 81. Then pull your variables down. You got x to the 4th. Y to the 0 doesn't matter. The next one has a little more pizzazz. So on this one, what numbers do you need to multiply together? 4, 3 cubed, and negative 2 to the first. Okay, that's not horrible. 27 times 4 is 108. So times 2, negative 2 would be negative 216. X to the what? X to the third, and y to the, just keep your powers you originally had, y to the first. Those should still add up to 4 here. Do it again. This one I would need to do 6 times what? Okay, yeah, 3 squared, 9, and then negative 2 squared. So is this one going to come out positive or negative? Since we're squaring it, it's going to come out positive. And actually, this is kind of a fluke. This does not normally happen. Don't think this happens. That one also turns out to be 216. And you usually don't get the same number twice. That's just kind of actually a little bit freaky. And then what power is on my x and y? X squared, y squared. Keep pulling those powers down. All right. Fourth term. I take 4 times what? 3 to the first and negative 2 to the third. Okay, should this one come out positive or negative if I'm taking the negative number to an odd power? That's going to stay negative, so it's going to be a minus. That's going to be 4 times 3 times 8. 12 times 8 is 96. And I would once again pull my variables x to the first, y to the third. And then last but not least, you can forget the 1 to the 0 power. That doesn't matter. It's going to be 1. So I just have to work out negative 2 to the 4th power, which is going to be positive 16 by its 4th. And ta-da! You've expanded your very first binomial. Was it horrible? It was horrible? Okay, think about it. Foiling all that by hand wouldn't be more horrible? I see a lot more errors if I see it foiled by hand. Okay, notice what happened to the pluses and minuses. What's the pattern on the pluses and the minuses? It's alternating. If there's a minus to start with in the original problem, it will alternate. The first term will always be positive, and then you'll go minus, plus, you'll just alternate. You really don't have to worry about the pluses and minuses. If the original problem is all pluses, what's going to be in there in the expansion? All pluses. That whole thing will be pluses. If it's a minus in the original problem, then you'll alternate. And you would get all those terms. Now, if you want to complain to me about it, I'll give you 1 to the 10th power come test time. We could do a 25th power on your homework. That'd be fun. I've never done one that big. That might be quite interesting, although the numbers would be astronomically big. It would be horrible. I don't know. Wow. You'd have the coefficient numbers, by the time you multiply it out, would be big. So we probably won't do that. Okay. Do you think you can do an expansion on your own? Could you redo one of those? Or do I need to do another one? So we're going to do some more of the same, except I'm going to show you how to shortcut. Not this. A full expansion, that's the best way to do a full expansion. If you need all the terms, that's the way to do all the terms. But if you don't need to do all the terms, sometimes I'm going to ask you to just find a single term out there. And I don't know where I threw my notes when he came in. Hold on a sec. Did I get that? No, I didn't. Okay. Suppose I said to you, find just the 7th term in an expansion. I want you to find the whole mess. I just want you to find me the 7th term of the expansion 5x minus 4y to the 10th. Okay. Well, does that mean you have to work out the whole expansion just to find the 7th one in the list? That would be horrible. There's got to be a better way. So let me point out using the one we just did. This would be the first term, second term, third term, fourth term, fifth term. What do you notice about the power on y when you look at the term number? First term, power on y is 0. Second term, the power on y is 1. Third term, the power on y is 2. Fourth term, it's 3. Fifth term is 4. So that means, yes, if I say find the 7th term, then that means your y will have, it'll have a 6th power on it. So in this case, though, since it's negative 4y, you will have negative 4y to the 6th power. Well, basically you work these from back to front. So now we have to figure out, okay, I have 5x, what power would be on it? Since the whole thing was a 10th power, what do we know about what those two powers together have to do? They have to add up to 10. So if this is a 6, that means the x's have to be 4, because the two powers, 4 and 6, have to make 10, that you started with. Okay, now, here's a little differently. How on earth am I going to get that crazy coefficient? Are you really going to wide out all of Pascal's triangle to go find one little number in the triangle that you need for this one spot? Probably not. In this case, it's quicker to just get that number, that coefficient in front, using the combinations. Because you'll notice when I wrote the combinations out here, the first term was at 5C0. The second one was at 5C1. The third number in the triangle, in the row, was 5C2. So it's also one less than the term you're on. So in our case, our front number on our combinations is what? 10. We're doing 10th power, so we're 10C. It's still one less, just like we did here, 10C6. Same thing goes there. You do one less. In actuality, because 10C6 and 10C4 are the exact same number, if you just use either of the powers you've got up here as your second number in your combination, it'll always work out right. So you could do 10C6 or 10C4 and you would get the same thing because they are the same number every time. And then you'd have to crunch it out. And this baby you'd want to crunch in a calculator because this is a big number. So you'd actually, I would go work out in my calculator what's 10C6 times 5 to the 4th times negative 4 to the 6th. And you're going to get a pretty good sized number. Should come out 537,600,000. X to the what? X to the 4th, y to the 6th. X and y are easy. It's that front number. You can see how big these can get. If you start doing a 10th power, these numbers can get whopping big very, very quickly. Do I need to do another one of those kinds? We have time. We should do another one of those kinds. I don't trust. Find me the third term. We won't go big. Of 7x plus 3y to the 6th. I want you to find me the third term. X, 3y. Okay. Start from the back. What power should go on the y? Y the second. If this is third, they want you to find third term. Then you do second. Go one less. So then how do you figure out what term goes up here on the x's? Since we're doing a 6th power, 2 and what makes 6? 2 and 4. So that has to be a 4th power. And then I have to throw the combination in front. How do you always know the front number of the combination? The total power, which is 6. How do you know the second number of the combination? Yeah, one less. If we did third term here, we do the same thing here, one less, so we'll do a second power. So then you just have to work out what's 6C2 times 7 to the 4th times 3 to the 2nd. Okay, 62 is 15, but 7 to the 4th is bigger than my brain's going to do. Anybody, are you calculating for me? You probably better read it by digits, because I don't know this one. Oh, that's not so bad. Okay, 324,135. X to the what? X to the 4th, y to the 2nd would be that third term. Okay, and you're probably going, why would I care? Why would I want to find that term? Yeah, unless you're doing some major mathematical messy proof stuff, you probably don't care. But that's how we use probability. What you just did there is the same thing. I'm going to change it into finding probability, believe it or not. So that's the cool part. And